This is a continuation of section 9.3, and we are transforming systems of equations into row echelon form. So here's a second example. Just got done showing you the first example of putting a system similar to this into row echelon form. Now I've chosen this one because for a couple of reasons. First of all, when you get it into row echelon form needs to have three equations. The first one needs to have one x. So 1 is a coefficient, x. You don't have to write down the 1, but I'm putting it there so that you can emphasize that. And then it's going to have something y, something z equals some number. So it's got to have, the first equation has to have x, y, and z. And it has to have a 1 there. So here's the dilemma, one of the dilemmas, is that none of these equations have all three variables in there. So I know that that tends to freak students out because they're like, how am I going to get that when I don't have any equations with x, y, and z in them? And I'm going to address that. Also, what if I don't have an equation that has a 1x to begin with? How do I make that happen? Because I know that causes panic for many students as well. And so I'm going to talk about strategies for making that happen. The second equation needs to have y and z in it. So it needs to have a 1y and then something z equals some number. Now I do have an equation down here that has y and z. So if you wanted to, you could easily just move that equation to be your second equation. And that way you have a y and a z, and then it'd just be a matter of changing that to a 1. So that is something that you could think about doing. And then we need to get the last equation to just be 1z equals some number. Now, what that means is that I need to have this be a 0x, this have a 0x and a 0y. So normally I don't have those filled in, but I want to show that those are indeed there. So in the last video I talked about that there's basically a process that I usually go through, and it's very systematic. And if you follow this order, it's going to help you get these problems correct. The first is to try to get this 1x in that spot. So that's the first step. I'm always trying to get that into place. Then my second step, as you'll see, is to get both of these to be a 0x. As I said, one of them is already a 0x, so that's half done for me already. I'm not even to that step yet. But again, don't get ahead of yourself. Don't get too caught up with going, oh, well, there's something missing in this one here, so that's good, when you may do something, pardon me, I already sneezed. They can talk. Okay, so anyway, that's great. Luckily nobody's here for me to sneeze in front of. But anyway, don't get caught up in doing anything other than this first step. Don't be looking ahead and going, well, I've already got this one missing or whatever, because things can change, because getting that to be a 1 might cause other things to change. And so if you get ahead of yourself, that's going to be a problem. The third step the board is not cooperating with me. Pardon me for a second. Gotta back this up. Okay. So the third step is to get these two terms to be the way they are. And it doesn't matter which one you do. Okay. A lot of times I will get the 0y in place and then worry about getting that 1y at the very end. But you can get the 1y and then use that to get the 0y. So either one of those is interchangeable. And then the last step is to get this 1z, that's the fourth step, get that to be a 1z. And when you get down to that one, you can't use any of the other equations anymore. Basically, you can use any of the equations together to do step 1. Then, to get these zeros, you're going to use equation 1 and the other equation that you need to get a 0 here. You're going to use this equation and one of the other ones to get these to be zeros. Once you're done with this column, you get a 1x here, a 0x here, and a 0x here, you're no longer going to use that first equation anymore. Now, when we get down to here, these are gone. So basically I have a system of 2 equations, 2 variables left. So I'm only going to use those 2 equations together to make this a 0 and make that a 1. Then, once I get down to just trying to make that a 1z, I'm not even going to mess with the first 2 equations. I'm only messing with that one. I'm going to divide by the number in front of the z to make that a 1, and then I'll be finished with the problem. So it's very important that you understand there's only certain things you can use, because if you try to use this first equation to make that a 1z, you're going to be adding to these other terms that we've already completed, and you're going to be undoing things. So that's important. Okay, so let's take a look at how to go through this process. So I need to have a 1x up here at the top. And so it's very similar to doing the elimination method, but instead of eliminating the variable, what I want to do is combine my 2 equations together somehow to get a 1x instead of getting a 0x. The elimination method normally gets you a 0 for a term. It completely eliminates it. But in a similar fashion, you can not quite eliminate it, just make it be a 1. So what I'm saying here is, I see this 2x and this 5x. If I take this first equation and I multiply it, I'm just going to do this as scratch work off to the side. If I multiply it by -2, that would become -4x minus 4z equals -4. And then use this second equation, 5x plus 3y equals 4. I can add these 2 equations together. By multiplying that by -2, I've created not opposites, but almost opposites. These are close to being opposites. They're 1 away from that. So when I add these together, -4x plus 5x gives me a 1x. And nothing plus 3y gives me 3y. And -4z plus nothing gives me a -4z. And -4 plus 4 gives me a 0. And so what I do is I'm doing kind of like the elimination method, to combine these together to get a 1x. And then I'm going to replace that top equation, because that is what the third rule that we learned tells us we can do. You can combine any 2 equations together by doing the elimination method, basically, or the process that's like the elimination method, and then you replace one of them, not both of them. So I'm going to replace this top equation with the new equation I have, which is 1x plus 3y minus 4z minus 4z equals 0. Now, I also am I'm thinking ahead, I'm going to go ahead, and because I need this equation here to have y and z without an x, this equation right here fits the bill for that. So I'm going to take these 2 equations, and I'm just going to go ahead and switch them around, just saving myself a little space. Hopefully that's not too confusing for you. So 3y minus 4z equals 4, and then this equation is going to go down here, 5x plus 3y equals 4. So far, I got the 1 in its place, but I also have this 0x in its place. So the next thing I have to do is get this other 0x here. So I need to make that a 0x. And you do that by doing the elimination method. So I'm not going to change the top equation. So I'm just going to recopy it. I'm not going to change the second equation. I'm not ready for that yet. But I'm going to change this equation. So now, this is where I do a little scratch work off to the side. Okay, so I'm going to erase all that stuff because it's kind of in the way. I want to make this a 0x. So I'm going to do the elimination method. I'm going to use this top equation. I'm going to temporarily multiply this top equation by -5. And then I'm going to add the result to this equation. So I'm going to do that work off to the side. I'm temporarily multiplying the top equation by -5. So -5x minus 15y plus 20z equals 0. The bottom equation is 5x plus 3y equals 4. So this is the top equation multiplied by negative 5. I'm not replacing it, I'm just using it temporarily. The bottom equation is 5x plus 3y equals 4. When I add these, this gives me 0x minus 12y plus 20z equals 4. So that is what I'm going to replace this equation with, because that's the rule. Combine two equations together, doing the elimination method process, and replace one of them. So now I get a negative 12y plus 20z equals 4. So I now have a 1x here, and I have my x terms missing. So I am finished with step 2. Now that I'm done with step 2, and I move on to here, now I'm no longer going to use that top equation. I'm only focusing on these two equations. So these two right here, and I have to do two things, and it doesn't matter which order you do them in. I need to make that a 1y, but I also need to make that a 0y. So like I was saying earlier, a lot of times it's easier to get the 0y there first by combining these two together, doing the elimination method, and then change that to a 1y. So that is what I'm going to do. So I'm going to erase this to make some room. The nice thing is, if you didn't get that, you can rewind it, go back to it. So I'm going to take that equation, that system, and I'm going to recopy the top equation, because from here on out, the top equation does not change. It's just kind of along for the ride. I want to make that a 0y, so I'm not changing this 3y minus 4z equals 4 yet. What I'm going to do is figure out what this equation is going to be, and I need this to be a 0y. Okay, I don't have to write that there, but I want that to be a 0y. I need to figure out what's the rest of it. So how do I do that? Well, I am doing the elimination method with these two equations. So I'm going to take this top equation and I'm going to multiply it by 4 and then add it to this one. So I'm just temporarily multiplying this one by 4 and adding it to this one. Why multiply it by 4? Because that would make that a 12y. This is a negative 12y. I'm creating opposites. It is the elimination method. So I'm going to do that over here since I have a little bit of room. 12y minus 16z equals 16. And then this one is negative 12y plus 20z equals 4. When I add those together, I get 4z equals 20. So that is my new equation here. 4z equals 20. So now I have the stair step. I have one x here. I've got no x's below it. I've got 3y and no y below it. And then I've got just z here. So I've got the stair step, but the problem is that this and this are supposed to be 1s. That's supposed to be a 1, that's supposed to be a 1. So that gets me to my last step here, is that to make that a 1, I can divide all of these by 3. To get that to be a 1, I can divide both of these by 4. And when I do that, again, the top equation is just x plus 3y minus 4z equals 0. This becomes y minus 4/3 z equals 4/3. And then this one is z equals 4. So this is row echelon form. That's what it wanted. Then I'm supposed to do back substitution. So what that's saying is right now I'm looking for my order triple. I now know that z is 4. So I can put 4, I can substitute that back into here and get y minus 4/3 times 4 equals 4/3. So y minus 16/3 equals 4/3. When I add that, I get 20/3. I feel like I made a mistake somewhere, and now I don't know where that mistake was that I made. I now know where it is. This is actually z equals 5. Would help if I divided correctly. 20 divided by 4 is 5. So that's 5. Okay. I knew I was hoping I'd figure it out somewhere here so I didn't have to start all over. So anyway, now when I add that, y ends up being 24/3, which is 8. Whew, thank goodness. All right, so then when you substitute 8 and 5 back in here, so you put 8 here and you put 5 here, you will get the solution. This has just become another mess because the board did not like what I was doing. But we come up with x being -4. So then there's my solution. Now, there are a couple of things that sometimes come up that you need to be aware of. And so I'm going to pull that up here. This is not in your notes. But sometimes, either when you're in the middle of solving a problem or when you're given a problem, like you might be, like if in the book they give you a system and the system has like x plus 3y plus 7z equals 12, and then you've got like 2x plus 9y minus 8z equals 20. It just totally made that up. But there's not a third equation. You have 3 variables. If you have 3 variables, you need 3 equations to come up with a single point for a solution. If you don't have a third equation, then that is actually going to be an infinite solution case. Okay? So what you do is you go through and you solve it the same way you normally would. What you do is you get that system down to a point where you have like 1x plus 4y minus 3z equals 8. And then the next equation might be like 1y minus 2z equals 7. I'm totally making this up, but there's a missing third equation. So what you do is you let that equation, you make up your own. You let 1z equal, and you let it equal a. Because there's infinite solutions. So what you're going to have is you're going to have an ordered triple, but the z you pick to be just a variable a. And then what you do is you do back substitution. You take this value and you plug it in here. And so you'd have y minus 2a equals 7. So you solve for y equals 2a plus 7. So that's what I would put here, 2a plus 7. And then you go back to the first equation and you substitute this in for y and this in for z. So if I go back to the first equation, x plus 4 times y, I just figured out that the formula for y is 2a plus 7. And then minus 3 times z, which is a, equals 8. And I have to simplify this. X plus 8a plus 28 minus 3a equals 8. So I get x by itself. So I move the 8a and the 3a, that's 5a, to the other side. It becomes a negative 5a. And move the 28 to the other side, that becoming negative 20. That would be what I'd put in here for x. Negative 5a minus 20. So now I have infinite solutions, but this is the formula like we did with 2 variables and 2 equations to come up with a formula that generates a list of all the ordered triples. Now the no solution would basically be if you're going through and you're solving a problem and you have your 1x, your 1y with something here equals something, okay, and then that's going to be a similar case where you're going to get something like they eliminate out, but instead of getting like 0 equals 0 here, And that's the case, like if you're doing the infinite solutions, you'd end up with a 0 equals 0, so you just change it to z equals a. If you get something like 0 equals 12, that's not true, that would be no solution. Okay, so those are a couple of special cases that do come up. You're going to see those in the suggested problems in the book.